Hey, what's up everybody? Fifth state of matter, which may probably exist a lot in the universe. We are going to see the fifth state of matter, which is hard to create on Earth and do the research. In this video, we are going to discuss who gave the idea of BECs, nothing but Bose-Einstein condensates, who practically proved it on Earth, how do we create it, and what are the conditions for creating it, what are the challenges the scientists have to face in creating it. What are the uses of doing research on these Bose-Einstein condensates? Let us jump into the video and answer these questions. If anybody is new here, please consider subscribing our channel. I have an idea of introducing something new to our channel. I would like to call it as Saturday Updates, in which we are going to see the previous week's inventions, discoveries, or an incident. And this video will be not more than 5 or 6 minutes. In this video, we may see one invention or two depending upon its importance. Now, there are 4 states of matter which are common in everyday life: gases, liquids, solids, and plasmas. However, a century ago, 2 scientists proposed the fifth state of matter called BECs, Bose-Einstein condensates. Yes, BECs were just an idea. Their existence was first predicted by 2 important scientists. First one, a very well-known mathematician and physicist, Albert Einstein, and the second one, Indian mathematician and theoretical physicist Satyendranath Bose, gave the idea if certain elements are cooled to near absolute zero, that is 0 Kelvin or minus 273.15 degrees Celsius, Bose-Einstein condensates could be formed. Using this idea as a base, first BECs were produced on June 5th, 1995 by 3 scientists, by Eric Cornell and Carl Wieman at the University of Colorado at Boulder, NISTJILA laboratory, using gas of rubidium atom cooled to 170 nanokelvins. And shortly thereafter, Wolfgang Kettel, MIT, produced with a gas of sodium atoms, for which all the 3 received the 2001 Nobel Prizes in Physics. If you are asking me, these were produced 25 years ago, and what is the need to know about it now? Yes, there are a few. Yesterday, there was an update related to this. Scientists could achieve this Bose-Einstein condensates in the space very easily, which I wanted to share with you. That's why this video, Bose-Einstein condensates. When you take a group of atoms, especially gases, and cool them near to absolute zero, they begin to clump together, that is join together, and starts to behave as if they were one big superatom, which we call it as Bose-Einstein condensate. Though they created 25 years ago, still they had to face a number of challenges to create them on Earth. BECs are created in hundreds of labs across the world. There were 2 challenges which were faced by the scientists. One is the gravity on Earth, and the second one, the setup that is used to make them. What is wrong with the gravity? These Bose-Einstein condensates are extremely fragile. Even the gravity can affect them. And the second one, the setups which are used for making them are incredibly delicate. So these 2 limitations on Earth do not allow the researchers to do any experiment on these superatoms. Therefore, scientists wanted to try in microgravity. So they developed Cold Atom Lab in the space station to create Bose-Einstein condensate, which was launched in the year 2018. The Cold Atom Lab had a lot of advantages. It requires small amount of energy. Its size is also incredibly small, just 0.4 cubic meter, and total power consumption is just 510 watts. And the most important advantage, even after switching off the power, they can study about the superatom more than 1 second. Whereas on Earth, it was just 1/100th of a single second. And the fifth important one, they could create it in lower temperature. These were the advantages creating Bose-Einstein condensates in space. A gas of rubidium or a gas of sodium were the ones which were used for creating Bose-Einstein condensates. But now, The scientists are aiming to add potassium atoms to learn about condensate mix, and they are going to try creating spherical Bose-Einstein condensates, which is possible only in space. The so-called fifth state of matter, Bose-Einstein condensate, how is it created? We need to know one simple word called boson. Bosons are atoms that have equal number of electrons and protons. These bosons are cooled to absolute zero using lasers. What happens when we cool them? The atoms stop moving, or they slow down. As we cool the atoms more, the movement of atoms become less. At this stage, they introduce magnetic field, which traps bosons, creating particles wave, cramming them overlap into single matter wave. That is, which makes the bosons to form a big atom. Everything is fine. Created a new state of matter, doing research on it, got Nobel Prize. What are the uses of doing research on these Bose-Einstein condensates? Why do we need to create the fifth state of matter and break our heads? Yeah, there are valid reasons for it. Let us see that. It's very simple. By learning about them, we can come to know the working of nature more accurately than we have known so far. Scientists believe Bose-Einstein condensates contain vital clues to mysterious phenomena such as dark matter, dark energy, also called as unknown energy, which is thought to be a reason behind the universe's accelerating expansion, which we call it as inflation. In simple words, we can know about the working of nature more accurately. And it can also give us clues for solving the mysteries in the quantum mechanics. I hope this video might have given you some idea related to the fifth states of matter. If you have learned something new, give me a thumbs up. If any of your friends need to know about the fifth state of matter, please share the links with them. If you want me to talk about any of the topics that you are interested in, leave the topics in the comments below. Thank you for watching. Love you all. See you in the next video. Bye-bye.